All right, ladies and gentlemen, welcome back. Today we're going to be looking at graphing figures in the coordinate plane, and in particular finding the area and perimeter of figures in the coordinate plane. This is going to tie back to a couple of things we've done in the past. First off, it's going to tie back to Pythagorean Theorem on the warm-up that you've just recently done if you're in class, or the warm-up that you see on the board or on the video right now. You're going to need Pythagorean Theorem to find that missing side. That concept, and then the concept of finding distances between a couple of points in the coordinate plane is going to come in, and that's something that we saw last semester a little bit. Looking at this warm-up really quick here, finding, let's say, the missing hypotenuse if you're given a couple legs of a right triangle. You can go ahead and do that. Hopefully you've already done it on your warm-up by saying 3 squared. Let's see here, I'll put a 3 squared plus a 9 squared is equal to some missing side squared. We'll call it x. Put squareds on each of these. If you square each of these, 3 squared is 9, 9 squared is 81 is equal to x squared. And then from there, 9 plus 81 is 90, so 90 is really equal to x squared. Square root both sides, and you should get something a little bigger than a 9. Let me get my calculator here. Wind up with square root of 90 is about a 9.48, 9.49, somewhere around there. X is about 9.49. Like I said, this ties into graphing in the coordinate plane and finding area and perimeter. Alright. Suppose, let's start off here, suppose with this first example that you have 4 points, A, B, C, and D, and they make a figure. I'm going to go ahead and use blue here and start drawing. The point -2, 3. -2, 3 is going to be located left 2, up 1, 2, 3. This point right here. The point 2, 3 now, right 2, up 3, located right there. The point 4, -1, right 4, down 1. Located right there, and then the point -2, -1, left 2, down 1. If we place some connect the dots between all of these points, there, and there. What shape do we get? Think about it, look at it for just a moment. Looks like we get a trapezoid for this one. So finding area is not going to be too tough. We're just going to do our trapezoid equation, which, if you remember off the top of your heads, and many of you did, the mastery quiz went very well, by the way, B1 plus B2 all over 2, multiply that by the height. To get those values, we can write in a few distances. We know that the height here looks like it's 1, 2, 3, 4 up. One of the bases is 1, 2, 3, 4 right here. And one of the bases is 1, 2, 3, 4, 5, 6. Alright, so we can go ahead and plug into our equation then. 4 plus 6 all over 2 for our bases. Multiply that by our height of 4. Alright, area is all equal to that. 4 plus 6 I know is a 10. 10 divided by 2 is a 5. 5 times 4 is a 20. So we would say that this area of this figure is about 20 units squared. You can do pretty much the same thing by counting up the boxes. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and a couple of pieces that are going to add up to make a 20. All right. Now perimeter. Perimeter is going to be easy for 3 of the sides. We have a 4, and a 6, so we need to start adding those up. I'll switch over to red here. 4 plus 4 plus 6, but there's something else, this last side, that we need to add on to it. We don't know what that last side is yet, but we can go ahead and calculate it. Think back to last semester. Try to remember how we found those missing sides from last semester. Let's see if you remember right. Yes, we did indeed draw an extra triangle. I should really make this a dotted line here, but draw an extra triangle. We have a 2 by a 1, 2, 3, 4 triangle. right triangle, we want to find this missing side, we're going to do some Pythagorean theorem. This is 2 squared plus a 4 squared is equal to some missing side squared. We'll call it x squared. 2 squared is 4, 4 squared is 16. Add those together, that's 20 equals an x squared. Square root that, square root both sides, so on your calculator, square root of 20 is about a 4.47. Alright, so we'd say that this side is about a 4.47. So that's what we need to add right here, 4.47. Adding all these up, 4 plus 6 makes a 10, plus a 4 is a 14, plus another 4.47 should be an 18.47 units. Notice I didn't do units squared here, just units. If you have any questions, go and pause the video at this point. Otherwise, we'll continue on and find the area and perimeter of a couple other shapes. All right, looking at this next shape now. This is another one where we are given a couple of points. On this next page here we go. We were given a couple of points. We were given 4 points, in fact, and we're going to find the area of this figure given 4 points. So once again, I'm going to go ahead and start by plotting the points. 1, 2. Here we go. 1, 2 is going to be located right there. The point 3, 0 is right there. The point 1, negative 2 right there. And the point negative 3, 0 right here. We can place and connect the dots as well, just like we did last time. Think about what figure we got. Yep, correct. It is a kite. We do indeed have a kite. So for our area formula, we're going to go and write area formula 1/2 or divide by 2, either way, depending on what class you're in. We wrote a couple different equations. D1 times D2 divide by 2 for our formula. Looking at these diagonals, it looks like one of our diagonals, I'm going to draw these in blue, one of our diagonals is 4. All the way down, one of our diagonals is 4. The other diagonal is 1, 2, 3, 4, 5, 6 across. Alright. One diagonal is 4, one diagonal is 6. So we could go ahead and say area is equal to 4 times a 6 all over a 2. Well, I know 4 times a 6 is a 24. Divided by 2, we'd say that that area is 12 units square. And once again, you can start by counting boxes here instead if you'd like. I see about 6 full boxes in the middle, another almost full ones, another couple almost full ones, almost making 8. Maybe with these attached on, we'd make 8. Another couple bigger boxes. Between these last few, we probably have another 4 boxes, so a 12 makes a sense for the area there. Finding the perimeter now. We're going to go and do what we did last time. I'll draw this in green for a moment. We have another right triangle here. We have a 2 by 2 triangle, in fact, so we could do a calculation. 2 squared plus 2 squared equals x squared. Alright, so that's 4 plus 4 is x squared, so 8 equals an x squared. Divide or square root both sides. Square root of 8 gives us a 2.83 or so, 2.83. So we'd say that this side is about a 2.83. Alright. And incidentally, this side down here is also going to be a 2.83. That means that our perimeter is equal to 2.83 plus a 2.83 plus a couple of sides that we don't know yet. Alright, we need to find these last couple of sides. This last one, or this triangle here, is a 2 by a 1, 2, 3, 4 triangle, 2 by a 4 triangle. I think we already did that calculation. 2 squared plus 4 squared. Let's see here. 2 squared plus 4 squared equals, let's call it y squared this time, distance in the y direction here. 2 squared is 4, 4 squared is a 16, 4 plus 16 is a 20. Yeah, I believe we did do this problem here already. Square root of 20 ends up giving us a 4.47 again. 4.47. That's from the last problem. 4.47 right here, 4.47. Adding these all up, I'm going to go ahead and put these all in my calculator. 2.83 plus a 2.83 plus a 4.47 plus a 4.47. Add those all together, we're going to get about 14.6. All right. So we'd say that the perimeter of this figure is 14.46 units. Again, not units squared, but this is the distance around the kite vector, just in units. I'm going to take an opportunity to pause the video for a moment if you have any questions. Otherwise, we'll keep going on in a moment. All right, this last figure is going to look a little different. We do have another 4 points, and we can graph these points. The structure is going to be similar, but the last two problems have given us an equation that, or a shape that we know, like a trapezoid for the first one or a kite for the second one. We already know the shape, so it's not a mystery of what equation we need to use. For this one, though, these points 0, 2, we have point W, point X is at 3, 2, over 3, up 2. Point Y is located at 4, negative 3, 4, negative 3 down here. And then point Z is located at negative 4, 0 right here. Place and connect the dots with these 4 points. And it's not an obvious shape. This is not a trapezoid, not a kite, not a parallelogram. It is some sort of quadrilateral, but it's not something that we have a good equation for. Let's do perimeter first. And I'm going to show you why in a moment. So we're going to look at perimeter first. I'm going to draw a large box around this whole figure. All right? A large box, large red box around this whole figure. And I'd like you to do that in your notes as well. Go ahead and draw a box. If you have another color marker, go for it. But draw a box around this blue figure that you have. We want to know the perimeter of this figure. So we can go ahead and do things like 2 squared plus a 4 squared is equal to something squared. I think that's 4.47. I think that's what we said earlier. 2 squared plus 4 squared. That keeps on coming back to us. So this side here is a 4.47. This blue side, you know what, I'm going to draw this in blue instead. Blue 4.47. This top side is very clearly just a 3. It goes 1, 2, 3. This side on the bottom, we have a 3 by a 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8, yes. A 3 by an 8 triangle. If we calculate that out, 3 squared plus an 8 squared equals x squared. 3 squared I know is a 9. 8 squared is a 64, so 9 plus a 64 is going to give us a 73. 73 equals x squared. Square rooting that now, square root of 73 is going to give us an 8.544. All right. Square root both sides. 8.544 is equal to x. So I can go and write that in blue. On this side here, 8.544. Very last side now, I'm not even going to write it down. You know how to do this. We have a 1 by a 1, 2, 3, 4, 5. A 1 by a 5 triangle. We want to try to find the hypotenuse of the 1 by 5 triangle. So 1 squared plus 5 squared. Let's see, 1 squared is 1, 5 squared is 25. Add those up, you get a 26. Square rooting a 26 then, you're going to get about a 5.099. All right. This last side here, 5.099. Perimeter is going to be equal to all these sides added together, the 4.47 plus the 3 plus the 8.544 plus the 5.099. Add those all up together. I'm going to put those in my calculator right now. Plus 8.544 plus a 5.099. And we're left with a 21.113. 21.113. And I'll label that units. Now we want to find the area. Here's the catch. This shape that we have, it's kind of tough to split it up into pieces. There are a few ways we could split this up, but it's going to be kind of tough to split this up into some nice pieces. I see right away we could potentially cut off a triangle here, but what are we left with? We're still left with an obscure shape. Then we could cut off this piece at the axis, but we're still left with kind of an obscure shape on the bottom. So here's what I'm going to propose we do. Let's find the area of the whole rectangle. All right, the area of the rectangle. And by that I mean the red rectangle. This whole red rectangle is about 8 by a 5. All right? It's an 8 by a 5, which is going to be 40. Now let's find the area of each of these individual triangles. I'm going to just label these area 1, area 2, and area 3. All right? Area 1, area 2, and area 3. And those are going to represent area 1 right here, area 2 right here, and area 3 for each of those triangles. First one, we have 1/2 times base of 4 times height of 2. I'm getting that from these numbers here. Base and height of the triangle, 1/2 of 4 times 2. 4 times 2 is an 8. 1/2, that's a 4. All right. Second area, we have a 3 by an 8, so 1/2 of a 3 by an 8. I know 3, well, half of 8 is a 4. 4 times 3 is a 12, so that's got to be a 12 for an area for this one. Last one is a 1 by a 5, so 0.5 times 1 times a 5. Half of 5 is a 2.5. So now that we have that, we have the area of the whole rectangle. Let's cut off each of these triangles. All right. So area of our figure is going to be 40, and then we're going to subtract each of the triangles. So subtract the 4, subtract the 12, subtract the 2.5. Subtracting all those, I'm putting that into my calculator right now. 40 minus the 4 minus the 12 minus the 2.5. That's going to give us an area of 21.5. All right, area of 21.5. That's our final answer here. Area of 21.5, that's going to be our final answer. And again, the method that we used to find that, we found the area of the box that contains it. We drew a box around it, got the box that contains it. And then we found the areas of the little triangles that we cut off on the outside. It's a lot easier to cut off triangles on the outside than cut this into pieces. Because, I mean, look at this triangle on the inside. I don't know how big this base is. I don't know where this line crosses. So it's hard to kind of tell. It's hard to cut up this into the inside pieces. Let's cut off the outsides. Anyways, we cut off the outsides, found a total area. I should tack on that this is units squared once again. As always, if you have any questions, be sure to let me know. Shoot me an email. Rewatch the video. If in class you need to watch the video again, you can rewind it if you'd like, if you missed a part. Otherwise, your assignment for tonight is going to be in your books. Assignment, it should be written down on the whiteboard in a little bit here. I believe I have your homework calendar somewhere around here. Let me pull that up. If you have your homework calendar on you, that's going to be a lot easier. You can just look at that. Look right over here. No, never mind. Right over here for some books. You can find some books right over there. And geometry. Let's find that assignment for you. All right, assignment for tonight is page 620, numbers 10 through 15, and number 21. So go ahead and get to work. You have the rest of the hour to work on those problems. Have fun.